Welcome to another episode and video on my driving robot Mydfir, programmed in Python with active sonar on the right side of the robot and the left side of the robot. Line following sensors, two of them actually, and three lights to indicate several occurrences like presence of an object and some more stuff. The color recognition disabled for now, and last time I actually changed the algorithm for the sonar a little bit so it detects whether the distance is between 5 and 2 centimeters and smaller than 2, in which case the distance is absolutely unreliable. The measurement distance, that is. This is measurement, yeah. Now everything is of course dependent on timing, and currently upon examining the code again, the lights will blink in 1 second. So only 1 second, then 1 second off and another second. So that is a counting delay in which a lot can happen. So how will it behave now? Last time there was some improvement with the sonar, so let's do it again. And by the way, the robot is connected using the RF data link from fischertechnik, and the robot interface is equipped with a transceiver which acts as the counterpart. So let's do it. See whatever going to happen. Now by the blinking LED you can see what is happening, and this is not the intention. The point is that the red LED, the red lamp actually, not an LED, is sensing the right hand sonar and not the left, while the object was on the left. So that's one problem. And of course I can find it in the data file. And here the line following goes wrong. So let's see whatever comes from this. If it comes out of this. Yeah, self-correction, that's good. And another mishap. And by speed you can tell that the battery is fully charged, so that's good. And there we go again. And the left hand side of the sonar doesn't do a thing. So well, line following, knock on wood, goes fine until here again at exactly the same place. That's remarkable. Why would that be? Okay, one thing only, and it doesn't even bother to detect the object. So much for sonar. Let's see to the algorithm.
Okay, so the sonar works now. The line following works quite nice. The sonar, however, doesn't. And if we look here at the sonar, while the distance is larger than 5, okay, started it, and then I still don't know if that is entirely correct, but let's be. Larger than 2 and smaller than 5, then respond. And here I want to change something. 1 second, 1 second, 1 second, 1 second, 1 second. This is 5 seconds delay in the whole program. So let me bring this back to half a second. Oh, this will probably be 0.5. And then why don't I just copy it? No, the editor has a problem with copying properly. So let's not do that. And here it is 5 times. We even no, 1, 2, 3. Yeah, it's several states, so there are quite a number of them. Well, let's copy it anyway, and that should be here. Yeah, see, this copying goes wrong. 10.5 seconds. Way too much. Alright. And what do we have here? The same thing again. And that's it. So let's see how this behaves. And another thing is, let's see how the data is. That is even equally important. So I'm searching for S, which is not found. Really? That is remarkable. Alright, S1 is not found, and how about S2 is also not found. This is pretty remarkable because it did sense the sonar quite clearly. Alright, let's run it again and see whatever happens. And then it helps if I put the robot back into place where it very quickly senses the object. Always helps. Let me put it on some distance, not within 5 centimeters distance. Go. Alright, yeah. It clearly senses here the distance now. Distance is 2. which in itself is nice. However, can I sense this? Because this was, oh, no. Pattern not found. See, that is what I was lacking last time. Now it has, at the very end, seen S is 2. S2 is something. And this is S1. Oh, that's a very good one. I need to do right here as well, so I can see whether it is unreliable or not. So I will say this part, copy, yeah, I say unreliable here, but I really need to be written into the data file. And do I have it written as unreliable? That's an interesting question. So I say, that doesn't matter because it is not written into the data file. Now it will be. I can also do this. That's even better. This is a string, so let's replace this with this one. So now distance doesn't matter anymore. It is just that this is being unreliable, and then this will be written into the data file. That means that this whole string will have to be written here as well. Copy and paste here. And then this is of course S2, not S1. S2. Alright. Now let's see what happens. And first of all, of course, on camera, whatever happens.
Now, another thing that just occurred to me is that Sonar is dependent on the reflection of signals. So if it is like this, you will get a bounce of signals, and will it go like this, or will it be bounced in a straight line anyway? That's a very good one. That is the same question you can ask about stealth. If sonar and radar are being misled by reflecting, or more appropriately less or non-reflecting surfaces, then you might ask if this is a very good start. Then this one would be much better. So let me replace this one by this one. Certainly any object on here will somehow reflect it. And let's see how this works. There we go. 1, 2, 3. One, two, three, what? The program just goes on. It just doesn't write anymore. So I stop the program. I saw 3 flashes on the left, which is actually S2. Which is correct. It sensed it. "19 centimeters distance. "67. Oh, that's a very different object. So it sensed this one somehow, and it sensed a very different object, like I said. Now that's interesting. So let's replace this one by this one again. Let's put it like this, and then see what happens. One, two, three. It does. It does apparently reflect it and then stop because it loses the line. So stop the program, look at the data for S2. 97 centimeters. 97. Anywhere else? No, something at 97 centimeters. That's not the object. Or it's something else. That will probably be the other object out of view and not part of the experiment at all. And it happened here, so it indeed doesn't sense this one. So using this again, let's see how this works out. Waiting for 1, 2, 3. It loses the line. But something else I expected is it doesn't go backwards, which I had hoped it would do. Stopping the program again. Looking at the data. "72 centimeters. I don't think so. So that is yet another object and not this one. Makes me curious. So what happens when I put that object in front of that one? Like this. What will happen now? One, two, three. And this is exactly what should have happened. 1, 2, 3. And it loses the line. But this driving backwards is exactly what should happen anyway. Yes. Now looking for the detected distances. In this case S1. Oh, that's interesting. S2 is 2 centimeters. S1 is unreliable. Very interesting. And that's all it says. So here it says 2 centimeters distance, which I don't get. And this one says it's unreliable because it's shorter than 2 centimeters. Really. This invites to more testing.
Alright, so now the point is, of course, as you can see here, S1 gave 2 centimeters. That maybe so I realize because Sonar is, oh wait a second, 2 and unreliable. And 2 being the minimum distance, I'm talking about S1. S1 is right here, and how can this be? This is strange. Very strange indeed. Here it gives a very clear condition of larger than 2 centimeters. So if this condition says larger than 2 centimeters, then why does it say 2? And this one says less than or equal to 2 centimeters, and it says unreliable. And this is S1. Oh wait, this is both S2. No, it's both S1. I read wrong. First it is 2 centimeters and then it says unreliable. Oh, that makes even less sense. S1 is unreliable. Here I say distance is converted to string in order to write it to the data file. So here it measures a distance of 2 centimeters. However, that would be impossible because 2 is 2 and not larger than 2. Really? Well, unreliable is unreliable, that is for sure. But how can this one measure 2? 2 could not even be measured or end up in the data file. Anyway, is there any more S1 than that? Apparently yes. S1 is 76 centimeters, which, and S1 being red, S1 is being red, so yeah, alright. So it measures something being there, but larger, further than half a meter away. Calculating with an angle of 30 degrees, in which you can find objects from the sonar. Interesting, let's measure that. If this is indeed the case. That is very interesting. No, not here, not here, here. So here's pattern not found, and here it says at the very start. So for the 76, I'm quite curious what it is.
Last part for this episode. So I want to know which is which, and with this triangle and this measuring lint, let's use it for this sonar. And let's make it reliable, more or less. Alright, then 30 degrees is here, so it goes in this way. 76 is this, and then I find that it is quite possible to the earlier mentioned object, which is no part of this experiment, but certainly measured. So now I've confirmed that 76 is actually a very reliable output. 30 degrees in that direction. 30 degrees in that direction, that's another one, very possible as well, and that is less possible, much less possible, because the nearest, on the other hand, if I look at this way, then the nearest object, let's put it here, is further away than 76 centimeters. And in this direction, it is very well possible. So yes. All right. Next thing, what to do? Well, very curious about how the number 2 gets into the data file with the new algorithm. It shouldn't be, but it is, undeniably. With this object, it's a no-go. That is very clear. I can use it with the camera, but with the sonar, unless I do it something like this, or which is also an idea, of course, but that one is much better. Yeah, quite some new experiences and more reliable outcome than initially thought. And with that, I thank you for watching. If you like this episode, if you like this video, please subscribe to my channel, give it a thumbs up and leave a comment if you like, very much appreciated. You can also follow me on Twitter, if so retweet and like and leave a comment. You can also follow me on Instagram and like and leave a comment. Please donate to keep videos coming to you. Much appreciated. Also, you can become a patron and have your name mentioned on either just my website or also with my videos, and that depends on the pledge you make. For more information, please see my website, and on my website are much more links, information, etc. and pictures. I also have a lot of pictures on Flickr, and a link to that also on my website. And with that, once again, thank you for watching, and this is going to be continued. So yes, bye bye.